And I would now like to welcome on stage our next speaker, Andreas Vogler from Technology and Innovation Management. Hi, Andreas.
Hi, thank you very much.
Hello.
Hi.
What a perfect link, right?
Yes, absolutely.
There's nothing more I need to say.
Okay, let's now jump into Apache Kafka with WinCC Unified together to bridge the gap between the IT and the OT. I missed that. Okay, thank you. So, let me first start with Apache Kafka. What is Apache Kafka? Well, Apache Kafka is a distributed stream processing engine and platform. And what is stream processing? Well, stream processing basically gives us the possibility to analyze and manipulate data as soon as it is generated or received in real time into the system. And that allows us to gain insights on that data immediately without any delay. So what is the customer value of it? Well, that's nowadays easy because data nowadays equals to value. So we need data to train AI models. We need the data, the real-time data then from the shop floor to do the inference with that models, to gain insights out of that. And we need data to make data-driven decisions. And of course, also there, it matters if I have real-time data or if I have old and outdated data. And I have to note here, with real-time data, I mean near real-time data. So I'm not talking about hard real-time. Yeah? So it is all about utilizing the gold mine of your data. So we want to enable you to get empowered to do more with your data. We want you to get enabled to get the data out of your factory, out of your machine, and move it directly into the world of IT. And, well, that's all about making decisions based on real-time data. And then it is about becoming a data-driven company. So here we see on the left side batch processing. So this is typically the area of databases, data lakes, data warehouses, where we typically get data out from a source periodically. And then we transform it, and then we bring it to the database. And then we can do the analytics on top of that. And when we compare that now to stream processing on the right side, we have this data in motion. So the system is getting data into it all the time. So the data is always in motion, the system is always changing. And we can react on that data immediately without any delay again. So let me show you what we did in a proof of concept here. So we have taken our SCADA system, WinCC Unified, which runs on the PC, but also on the WinCC Unified comfort panels. And we have used here WinCC Unified SCADA system because SCADA systems are made to connect and to collect sensor values. And you can also add additional information to it. You can add semantic information. You can transform raw values to engineering values. And then what we did now is to build a connector to Apache Kafka to bring the real-time values again from your machine directly into Apache Kafka. And then on top of that, just for this use case, we have used imply.io, which is Apache Druid in the cloud. And Apache Druid is a real-time analytics database. So this can handle SQL queries very fast. And also, on top of that, we have used a dashboarding tool, which is included in imply.io to create dashboards with all the data of all of your machines. Yeah? And so we are here at the stage that we can visualize it, we can analyze it visually to gain insights out of that. And just to emphasize it here one more, it is very easy to get data from Apache Kafka into different databases. This can really be done with just a few clicks. And on the right side, we see, of course, also data scientists, machine learning. Well, what do we need to train AI models? Of course, first of all, the historical data, which we have now in the database, in Apache Druid in that case. And then we need to apply those models. We need to do the inference. And here we need the real-time data to do the inference with these trained models. And that data we can now also get from all of the machines, from Apache Kafka, from WinCC Unified. And then with that we predict the future. And by predicting the future, hopefully, we're again gaining some insights how to change the settings of our machines. And that's also an important point here. We are also able to then bring back these insights back to the machine. Again, via Apache Kafka to WinCC Unified and then to the machine. So it's all about to optimize your machine, to reduce downtime, to increase the speed, and to improve the quality. So some more use cases. Well, machine learning, I already mentioned it. Anomaly detection, predictive maintenance, microservices. So you can build now microservice architecture based on Apache Kafka, and now with events from WinCC Unified. Data stores. So with Apache Kafka, it is easy to bring the data to almost any kind of database. So that means now for you, you can store your data in that database which fits best to your use case, to your needs. Data replication, I will come to that on another slide in more detail. So why Apache Kafka? Well, Apache Kafka has a huge ecosystem out there. A lot of software, a lot of tools can deal with Apache Kafka, can talk to Apache Kafka. And also Apache Kafka was made to handle data in motion at a very large scale. So it can handle millions of messages per second. It was built from ground with cluster technology, so it is high available. And if you need to scale out, if you need more processing power, then you can add more nodes to it and you're done. And it is open source. So you can use it, you can download it, you can install it by your own, you can maintain it by your own. But if you don't have the needed skills for that or the resources for that, then you can go to Confluent. Confluent is the main driving company behind Apache Kafka, and they have services in the cloud. So you can easily, very fast, within minutes, start up an Apache Kafka cluster in the cloud, and you don't need to maintain it by your own. So Apache Kafka, on a very high level, implements the publish-subscribe pattern. And same applies to MQTT. And so we thought, in this proof of concept, why not also add MQTT as an option? So we can publish data from WinCC Unified to MQTT. And because we can also add semantic information to the tags, to the topic structure, then it can also fit to the unified namespace architecture. And we can also implement message formats for OPC UA pops up. So then we are also compliant with OPC UA pops up over MQTT. I will skip that slide for time reasoning. So one more use case, what we have implemented in this concept, to prove this concept one more time, let's say, we have taken or installed, we have used WinCC Unified in Austria and another installation in Canada, and via Apache Kafka in the cloud with Confluent, we replicated data from one side to the other one, and all that in real time. And for that we have used Confluent, so Apache Kafka, because the data streams in Apache Kafka also contains the history of the data. So that means if one side is down for a while for maintenance or for what reason ever, it does not really matter, because when it comes back online again, it can jump into the stream where it has left the stream, and then it can catch up all the missed values, so it will not lose any value. And on the right side, you see HiveMQ, MQTT broker in the cloud. So we have used here MQTT to replicate, to transmit commands from one side to the other side. So it was possible to turn on and off lights in Canada from Austria. And we also replicated or transmitted a live video stream from one side to another, from cameras, and all that again in real time. And there's one more thing. So on the right side, you see now WinCC Open Architecture on the bottom. Yeah. So WinCC Open Architecture has already a connectivity to MQTT. It can publish and subscribe to MQTT. So now we can even use both systems together and exchange data from one to the other seamlessly. So well, it's a proof of concept, but development is already in progress, so please stay tuned for more. Thank you.